And I will be presenting the assignment for 6.5. This is a review of parallel lines and perpendicular lines. For the sake of the video and to save us time, I've already pre-written a few notes in here, but what we need to remember about reviewing parallel lines and perpendicular lines is that we have an original equation that produces a line. We're looking for a parallel line that also meets this condition and passes through that point. Please forgive my camera, it will focus in and out. Ms. Spires has one in order to replace this one. I have done everything I can to figure out what's wrong with it. It glitches, so bear with me. Alright, so if we are looking for a new line that shares a parallel path, but also passes through the point -1, -1, we have most everything we need if we are trying to find point-slope form. We have slope, and they've given us a point. So this is our x sub 1, y sub 1, and we just substitute those values in. So we're going to have y minus a negative, so I'm going to put a little note here. Note that a y minus a -1 is the same as y plus 1. Please don't forget that if you come across negatives. Alright. Slope is 2. Again, same as the y, x will be plus 1. Alright, that's it. If you're looking for answers that are given to you in point-slope form, you're finished. It is that simple. Find your match. Negative, no negative. So, nope. Done. Alright, so what happens when we have all of our answers provided in slope-intercept form? Same process. You've been provided a slope. You've been provided a point. We just have to add a little step here or there. Y minus 5. Notice it's positive, so we can still do y minus 5 equal to 2, and x minus 2. Right? Oh. Now, I want to go the extra step because I know the form is in slope-intercept form. I'm going to bring that down. Distributing the 2, I get 2x minus 4. Now I use my inverse operations and start moving constants. Move the 5. Now I'm left with a y equals 2x plus 1. I am finished. Find your match. Done. Alright, I'm going to slip this forward. I haven't even looked up at the video yet to see how bad it's focusing in and out, but again, I have ordered one. I'm fed up with this thing. Okay. Same process, but what happens when we've got to take it all the way to standard? Alright, if you remember your notes from before and you took good notes, this should come really natural. Alright, we've only got a slope and a point. Let's plug them all in. Y minus 0 equals a slope of -5/4, right? Because it's parallel, so it's got to be the same. Remember, we're trying to find a line that runs parallel. I know I drew this as a positive slope. Please don't misunderstand. In your textbooks, a parallel line is represented, or a parallel situation, circumstance, relationship is going to be two slanted lines in your textbooks. That's just telling you parallel. But yes, it's a negative slope. I know it's going this way. So we're looking for two parallel lines, but the new one has to pass through that certain point. The point won't be in the textbooks, but I just put it there to remind you, you're looking for a line that has that relationship. Okay? X minus 4. Well, that tells me I've got a y equals negative 5/4 times x. Well, a negative times a negative is a positive, but that's 5 times 4 divided by 4. Well, the 4 just canceled, basically. Oh, good. But now we have to take it all the way to standard, and it's looking kind of messy. All right, that tells me I'm going to bring the 5/4 over here. I'm going to move x's and y's to the left. Everything's got to be on the same side in standard. All right, so we've got 5/4 x plus y equals 5. Well, it's breaking 2 rules. No, actually, no. It's breaking that 1 rule. No fractions. No negatives, but no fractions. In this case, we want to get rid of that 4. I'm going to slide up a little bit more. So I'm just going to multiply by 4. Everything by 4. That means the 4's cancel for this. I'm left with 5x. But I distribute the 4 all the way through the problem. And it's plus 4y's is equal to 20. And I'm finished. That easy. Which ones match? Nope, 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 yep. And you're finished.